Supplementary problem number 13. Mr. and Mrs. Patton and their and daughter Carolyn own three cars. Carolyn drives 10 miles per week, father with her car, than her father does with his Mr. Patton. Mr. Patton drives twice as many miles per week as Mrs. Patton. If their total mileage per week is 160 miles, how many miles per week does each drive? Okay, if we observe from the statement of the problem, I think something's missing here. Carolyn drive 10 miles per week, father. This should be something done, right? Done. So, Carolyn drive 10 miles per week, more than with his father's car, and her father does with his. So it means that Carolyn drive 10 miles more than his father's car. Okay, so I think we need to uh, restatement this part, the part of Carolyn traveling. So Carolyn drives 10 miles per week, father with her car does with Mr. Patun. Okay? Mr. Patun is the father. If we simplify this statement, it means that Carolyn drives 10 miles more than his father, which is Mr. Patun. Okay? If the father or Mr. Patun drive twice as many miles per week as Mrs. Patun, if okay, so it's somehow confusing, right? If we base our algebraic equivalent based on the statement of the problem, it will be confusing. So maybe we can simplify the statement to arrive with the correct statement and the correct equation, because our equation depends on the statement of the problem, right? So if we base our equation from the statement, it would be confusing. Carolyn drives 10 miles per week, father with her car, than her father does with his. So it's somehow confusing, right? So maybe we can simplify. Carolyn drives 10 miles per week more than his father. Okay? So if we let, okay, if we let, let's assume the smallest travel time. Mr. Patun drives twice as many per week. Mrs. Patun. Mrs. Patun got the. It is obvious in the statement that Mrs. Patun is not given the equivalent travel time. So maybe he is the smallest figure, because in a number problems we always start with the x as the smallest figure, smallest number, smallest integers with x. Okay, we let x be the number of miles traveled. Okay, so of Mrs. Patun, that is this is Mrs. Patun. Mrs. Patun. Okay, so we let x be the number of miles traveled by Mrs. Patun. How about for Mr. Patun? So Mr. Patun drives twice as many miles per week. So twice, 2x traveled. So this is Mr. Patun. How about their daughter, Carolyn, drive 10 miles per week. We simplify the statement, right? It is Carolyn drives 10 miles more than his father, Mr. Patun. So if we write that equation, uh, That is the father travel plus 10. More plus 10, right? Plus 10. Number of miles traveled by their daughter Caroline. So it's obvious na mas uh, their daughter Caroline is active driving because from the assumed quantities, he travels more. Okay, so let's formulate our final equation. If the total mileage, in this statement, if their total mileage per week is 160, we simplify the statement. The total mileage per week of the three is 160. So the summation of the following of the traveled. Okay, so the summation in our equation, we sum all the travel distances. We have the Mrs. Patton plus Mr. Patton, twice of Mrs. Patton, plus their daughter, greater plus 10, more than 10 from the statement, then equal is 160 miles. Okay, so how many x? 5x. So we transpose 10 to the other side, 160 minus 10, that is 150. Finally, x is equal to 150 over 5. So x is equal to, that is 30. So Mrs. Patun, which is our x, traveled 30 miles. How about the number of times traveled by Mr. Patun? That is twice. So this is 60, right? So how about for their daughter Caroline? That is 2x, 60 plus 10, that is 70. Okay, so if we sum the three, that is 90, that is 160 miles, which is equivalent to the total travel distance. So we can safely assume that if we check, so both sides is equal, so we can assume that the our answer is correct. Okay, moving on to our next supplementary problem.